Hey everyone, this is Zain back with another episode for Revision Challenge AS Computer Science. So today we'll go about a couple of topics. The first topic we're gonna go about is images. So there are two types of images that we're gonna study for our syllabus. The first one being bitmap images. A bitmap graphic is a rectangular grid made up of number of pixels. A pixel is the addressable smallest addressable picture element which can be represented in binary. The term bitmap comes from the concept that the bit patterns which make up the file are mapped to an area in the main memory. Each pixel will be a particular color. Each pixel's color will be represented in binary pattern. The contents of the bitmap file will be in this sequence of the binary color codes. There are several types of encoding and file formats for bitmap images. So first is monochrome. Monochrome is black and white pixels only. 16 color is when 16 available colors for each pixel. Then we have 256 colors, so it means that we have 256 possible colors. And 24-bit color is also known as true color, where there are millions of different colors. So let's work out each type of encoding that we just discussed. So monochrome will have 1 bit for pixel representation. So only 2 colors are required. So each bit can represent 2 different numbers, 0 or 1. So 0 will mean 1 color and 1 will mean another color. So only 2 colors. It could be either black and white, but mostly they are black and white. So 1 byte can store 8 pixels, since it is 1 bit per pixel. Then we have 16 color. For 16 color we'll require 4 bits. So in 1 byte we will have 2 pixels. And then for 256 color it is 1 byte. So each byte will store 1 pixel. Then we have 24-bit color. So 24-bit color is 24 bits or 3 bytes. So this is 3 bytes, so it means that this is 2 power 24. That will be a huge number, so it can represent 2 to the power of 24 different colors in a single pixel, and each pixel will have 3 bytes. So if we go about calculating what 2 power 24 is, it's 16777,216. So 16,777,216. So that many colors can be represented using 24-bit color. In addition to the pixel data, the bitmap will have other data stored in a file header. The header data will give the size of the bitmap, so the width and height measured in pixels, and the type of the bitmap. Bitmaps have the drawback that they have a large file size. If an attempt is made to over enlarge the bitmap with either editing software or just zooming in, this will make the individual pixels more visible. This is called the staircase effect. So let me just focus into one of these images and just show you this what I mean by staircase effect. So see, as I zoom in, you can see that you can see individual pixels being shown, even in this here, and it looks like somewhat staircasey. You can see that. So that's what I mean by staircase effect. You can clearly see the pixels in this image which I have focused. The clarity with which a bitmap image is viewed on a monitor screen will depend on two factors. The first factor being the resolution, the other resolution of an image or resolution of the image, and the other is screen resolution. The resolution of the image, the number of pixels per centimeter, a small image size made up from a large number of pixels will produce a sharper display. Screen resolution is the number of pixels which can be viewed horizontally and vertically on the screen. A typical PC screen resolution is 1680 by 1080. This is a key factor to consider when purchasing a monitor. So, what is the highest possible screen resolution that you can have? Vector graphic is made up of a number of drawing objects. A vector graphic program such as Microsoft Visual or Adobe Illustrator comes with a vast number of different objects organized into a groups of or shape libraries. Objects are organized into groups of shapes. The creator has selected a straight line from the connectors group and an LCD monitor from the computer program. Objects have properties. These properties determine the size and the appearance of each object. If an object is resized, its properties are simply recalculated. The advantage of vector graphics is that the changing size of any object will not affect the quantity of the drawing's appearance. That is, the object is scalable. So the next topic we'll move on to is sound. Sound is a key requirement for most softwares. Sound will be used for sounding context sensitive warnings, so basically the sounds that you hear on your phone or on your computer that are basically alerting you for something. It can also be used for playing back music or any sound, and most popularly nowadays for text to speech. A sound signal is an analog signal to be saved as data on the computer. The sound signal must be converted from an analog to a digital signal. For that, we use an ADC. So, what is ADC? So, the full form of ADC is analog to digital converter. So how would we convert this analog signal to a digital signal? The sound will be sampled at a set time interval, and these samples values from the binary values which form the sound file. The issue which affect the sound quality and the file size are sampling resolution, sampling rate. So sampling resolution is the number of bits used to encode each sample. So these values over here that you can see are digital are binary values, and what we need to do is we need to convert these values into bits, into binary numbers, so we can use these encoding for each sample that we have taken. So these green values that you see on the analog signal, these green dots are basically samples that we have taken. So what is sampling rate? Sampling rate is basically frequency of the samples taken. So how frequent you take the samples will also affect the file size and the sound quality. So higher the sampling rate and higher the sampling resolution, basically these will increase the file size and also will increase the sound quality. So if you decrease either of those or both of these, then the file size and also the quality of the sound will decrease. So we need to come up with some kind of a balance between these two, so that our file size is not too high and the quality of the sound is good as well. So there are certain types of software that we use to convert an analog sound into digital sound. So these softwares are generally used for recording and for digitizing the sound. What else are these softwares used for? These softwares are used for editing features as well. So there are several editing features that we should know about it. So editing features. So editing features that we should know about are basically cutting and pasting. We are already aware of what cutting and pasting is. So what we do is we cut and paste certain sections of the sound. Also, we can use this for filtering out sounds. So these sounds could be of either clicks or background noise. We use these softwares to filter that out. Also to record as a single, so that is mono, or two, that is stereo channels. So it is basically either the sound is coming from one way or two different ways, to left and right. Also, we use these softwares for normalizing the recording level. So sometimes what happens is when you are recording a sound and out of the blue certain sounds tend to amplify their sounds. So what we do is we normalize all of the sounds on the same level, so there is no amplification of one over the other. Depends on the work. And also to export the sound recording to different extensions. So these extensions could be .mp3 files, .mp4 files, maybe .wmv files. So different types of extensions that you already use. So this ends our topic of discussion for today. We discussed about images and sounds. So this is end of our day 2. Tomorrow we will continue with the same chapter, the first chapter, information representation, and we'll end this chapter tomorrow with 2 topics that are left, video and compression techniques. So see you guys tomorrow.